Yeah, hi everyone. Today question is lead code 962 maximum breadth ramp. Now in this question we have given a array nums and we need to find a pair I comma j. The condition of I comma j is I is less than j and nums of I value is smaller than nums of j, and we need to take the difference of j minus I. We need to maximize the difference of j minus I basically. This is the question, right? Let's say for in the first test case 608215, the first condition is we need to check I is less than j. After that the value of a of I, the value of nums of I is less than equal to nums of j, and we need to maximize the j minus I. Now here at index 0, at index 1 and index 5, 0 and 5, right, the value is 0 and 5, the index is 1 comma 5, difference is 4. In the second test case is the current index here is both the values 1 1, direct the nums of I is less than equal to nums of j, directly take the difference of the indexes and will return to go for. Okay, we will understand in notepad how can we do that. Let's suppose we are taking one test case 9 8 9 1 0 1 4 0 4 1, right? This is our test case. Now here what we can do here in this case, basically we are just going from the brute force approach ki how can we deal with this question. Now here the first condition is nums of I is less than equal to nums of j and I less than j. We need to choose a two element or one pair I less than j, and we need to take the maximize the difference of j minus I, right? The brute force approach is basically everyone is thinking about it. Like currently we are standing over that index I, right? Currently we are standing over index I. Let's say this is our index I or this is our index I. Currently we are standing over the index I. We need to check all the previous element from at index I whose element is less than or equal to the current element. Right now here how many element is possible is from less than of the current element of index I is this is 1 0, this one, this all the three element is possible because other element is already greater than the current index value. We need to choose 1 2 3, all the three element, right? This three element we need to choose. We need to choose all the three element at index at value 4, right? That's mean we are iterating our one loop for traversing the array at every index. After that another loop jth will be check our current index value is equal or less from the current value, right? In the left hand side they will check left hand side, or all we can traverse all the element from either from right to left or left to right up to end. Basically means we have to check 0 to ith minus 1 index how many element will be possible will be less than equal to our current value of I or I or j. Basically I, we can consider it here is I, right? Now here is we found three values, first second third. Assume that I is here, I is here. Now we are checking all that element from at index I minus 1 to 0 how many element is possible to check this one, this one, this one, this one, all the element, and this also 4 is also because we need condition the nums of I and nums of j will be equal, right? We need to check all the element in previous. to check the condition. That's mean one is traversal loop, one is for traversal, and another is for checking the condition, right? To 0 to ith minus 1. The time complexity will be O of n square, right? Time complexity will be O of n square, and space is O of 1. We haven't used any space, but here the constant already we are given. Here the n value is 10 to the power 4. That means we need to do in n log n or O of n. Otherwise they will give a TLE. They will give a TLE, right? This is the solution one. Basically this is a brute force solution. Directly we can currently go for index I and check all the 0 to I minus 1 index. Is it smaller value compared to the current index value? If it is there, then we can take the maximum index. We can take the index difference. Every time we can take the index difference and take the maximum, right? But this solution will give a TLE because time complexity is n square. Okay, we will go for second solution because if question is possible from n 10 to the power 4, that means solution definitely will be possible. It will be n log n or O of n. Okay, we are using same test case here. What is the test cases? 9, 8, 9, 1, 0, 1, 4, 0, 4, 1. This is our test case, right? Now we can go for second solution. Basically here in this solution we are using here first we will understand ki how to approach this, the second one solution. Now here is 9, here is 9, here is 8, 9, right? Just you can think about it. If this value is 9, after that we are going from next, this value is 8, right? Again value is 9. If here in this case, if we got the value of 8 here, is there any sense if the value is 100, 200, in the right side of 500, 1000, any of the value is there? Every time the value, every time or must be, we will choose this index because this index will be smaller. This index or that index will be smaller. We don't know which one index we need to choose, but every time we will choose this index or this index, right? Okay, assume one second, not here directly, we will not jump to this one. Assume that currently we are standing over the index I here at index 0. Now here in the right hand side, if any of the value like 100, 200, 500, 1000, 10,000 or 10 or 11, if any of the value will be come into the picture, or 9 also, if any value come into the picture, from greater than or equal to 9, definitely we will choose this current index I, because we don't have any option to choose, because left hand side there is no any element. We have, this is the possibility to choose this element if the element is greater than or equal to 9, right? We can map with at index 0, we can take the difference from current element minus the current I. Perfect. Otherwise we don't have any choice if the element is greater than 9, right? After that we are going from 8. Now here currently we are standing from 8. Here I is going from 8 here. If the value is greater, we are talking about a greater value. That means here is two conclusion from here. If the value is greater than 9, we can directly choose this index I, right? If the value is, that means ki current value is greater than current value here is 9, right? If the value is greater than 9, we can choose exactly index I. Perfect. Now if the value is now we can go for the next index. Next index is 8 and 1, right? Now 8 and 1, currently we are standing over at I here, right? Currently we are standing over I here. Now here we are checking. Already we have, if the value is greater, then we will choose every time index I here, this index. If value is smaller, what is the case? Now here we can choose both value 9 and 8, because we don't know about 100. Definitely 100 will be, we don't know about 100 or value is 10 or 11, right? We need to choose, we need to check both the value 8 and 9 both, right? Now here currently value is 9, after that value is 8. Now in this case 8, if the value is greater than, if the value is greater than 8, greater than 8 or greater than 8, right? We need to choose, if the value is greater than, let's work a current index I here, we need to choose here the value is greater than 8. If any of the value will be coming greater than 8, we will choose an index I or index I plus 1. If the value come from smaller, we cannot choose. Now here in the value is, if the value is smaller than 8, we cannot choose anything, because this will be because the condition is doesn't meet the condition, this condition doesn't meet a of I is less than equal to a of j, this condition doesn't meet. Now in the right hand side, if the value is greater, let's say 9, 10, 11, 10, let's say here is for 8, 9 is possible, 10 is possible, 8 is also possible, our answer, 11 is possible, 12 is possible, there is lots of answer will be possible from 8, right? But here 8, from 8 they will give same answer, right? But in 9, in the case of 9, we have a two possibilities here, right? From 9 and 8, here is 10, here also two possibilities. We can, because here we need to choose all that element here. We can, if any of the element from right hand side, we can choose 9 or 8 both, right? But in this case we can choose 9. That's mean if the element will be, we can choose element, if the element is greater, we can do a operation. If element is smaller from the current element, from the top element, we cannot do anything. Now here, that's mean what I am saying here. Now currently we are standing over I here. We can choose all the element from greater than 9. After that I comes to here, we can choose all the element from greater than 8, right? Greater than 8, if any of the element there, we can, this is our array, and in this array we can choose only 2 we can, they will choose that the element, they will choose which index we need to choose here. Let's say index 0, here index is 1, right? Okay, 1 second. Now here at index 0 and index 1, we need to choose which element will we choose. Now next element will be 9. In this case 9, the in this case 9, we already top element is 8, right? If we already discussed about it, if the top element, if our current element, the top element is 8, we already told that if element is greater than our top element, that is called as 8, directly we know the answer will be possible in this case, right? At index 0, at index 1 will be possible my answer. Got it? Which answer will be possible? At index 0, 1 wala answer is possible. Why? because this is will be give the minimum value, this is will be give the maximum value, right? Condition is met, this will be give the maximum value. The answer here is in this case 2. But how can we find it the answer 2? We will discuss after some time. Now here we are going from the next case from 1. From 1, the last value is 8, right? The last value is 8. We already calculated the answer from 9. Got it. If the last value is 8, now currently we are standing over index I, the value is 1. That means there is no any possible, because top element is already 8. We don't have any possibility to choose that element, because top element is 8. We can choose greater than element. If any greater than element will become, we can choose it. What happened? Yeah, if the greater than element will become, we can choose it, right? We can find the answer, but here the value is smaller. That's why we can include the value from here at index 3, 0, 1, 2, 3. If any of the value will become is greater than 1, if the any of the value will become in greater than 1, we can check from, in this case we can check here, because let's say the value will be 10. This is the we will choose this one. If the value is 7, right, the value is 7, we can choose at this index value, index 3 value. If the value is, assume that 9, we can choose 9 1 value. If the value is 8, we can choose middle value, this one, right? This is the possible answer, because every time the value will be changed, because we are taking the difference, index difference, and that's why every time value is fluctuating. Now here, after that, the value currently we are standing over 0. We can add here 0 at index 4, right? We can add here 0 at index 4. After that, next value is 1. We already discussed ki if the value is greater than the last index value is 0, right? Which for 1, which value 1 will we choose at? We have only two options, because at index 9, this 9 value 8 1 0 already stored into our index 0 1 3 4 is stored into our array, right? In this array we need to choose for 1, because last element is 0. We are choose a value greater than, because the current value is 0. The next currently standing over at index I is value 1. That means we have some possibilities to choose the element, the difference, because current value is greater and previous value is smaller. Previous value at index 4 is smaller, top value will be smaller. What does that mean? We need to choose which answer will be possible, because here the value is 8 9 1 0. This is the index, right? We are storing here index, this is the value. Can we say that here here is the current value is 1, right? If we need to let's for arrays like let's for arrays, here the, can we say that the array is decreasing order, because every time we are choosing the element at decreasing order, right? If the value is greater, we cannot choose 9 8. If the value is greater than 8, we cannot choose. If the value is smaller than 8, we can add into our array. Can we say that this is look like a decreasing array, right, concept? Or we need to find the current element value 1 index, nearby value 1 index. Is there any element possible nearby 1? Yes. Can we use a binary search concept to complete this, to solve this question? Like, let's say for binary search is what's 1 is 9 8 9, right? 1 8 9. We need to find element 1 or less than 1 element, all the values of 1 or less than 1 value element index. Which index will be possible? But here is this is the increasing order, here is decreasing order concept, right? This is the decreasing order concept. We need to find a 1 for, we need to check the value is greater than or less than equal to 1. Currently standing over I here, at index 3 here, we are checking. At mid is 8, we are now current value is greater. Mid is greater than our 1. That's why we can go right side, because if mid value is greater than, we can go right side, because right side will be value smaller. Now mid is here. Currently I start here, end here, started end. Currently mid is here. We are checking here. We already got the mid, right? If we already got the mid, we can update. We can. This is our answer, but assume that here is, let's say for assume that here is the mid is come from 0. Mid is come at from 0, but the but index 4, right? Index 4, but index 3 is also your possible answer in this case, right? So we can go from left side. So basically here we are using a binary search concept. You can check a binary search concept. How can we do that? This is very small concept to check smallest element in the array, target less than or equal to target, right? Now here we are storing the index basically, and the index, the value of the index is this 9810, right? We will find the smallest value with index, right? After that same thing we can do that up to end. Now every time we are, if the value is greater than our current, if the top element will be smaller than the current index element value, then we can do a binary search to find that element. Is it what is the smallest index? Those meet the condition, right? That's mean every time we are using the binary search, the time constant to this solution will be O of n log n, and the space complexity is O of n, because we are using here array or stack as you want, but we need a array because we are using a binary search in this concept. Okay, I will show you the code of this one. Now here we are taking the ramp. After the taking the ramp, we are start the for loop. In the for loop we are checking our size is 0 or not, and current element value is smaller than our top element of our list. If the top element of our list is value is greater, then we can insert our index, because if the value is greater, our top value is greater, then or your current value will be smaller. That's when we cannot find the answer, because we are array is decreasing order, look like that. Let's say for 3 to 1, like that. After that, if the array element is increasing, array element is greater than our top element, that's mean we need to find the answer, because current element, the test case like 3 to 1 and 7. In the 7 we need to find 3 to 1 is all the possible answer we have, right? 10 3 to 7, assume that in 10 3 to 7 is all the answer will be possible for the 7 current index. We are standing over the value 7, those index value 7, right? All 10 3 1 is possible, but only 10 is, we need to, here we are using a binary search from 10 3 7 10 3 to 1, which index will be give a maximum answer, right? Smallest index will be give the maximum answer. That is, yeah, this is fine. So basically we are finding the minimum index who is made the condition of nums of I is less than or equal to nums of j. After that, here we are using the binary search concept. After that they will every time if the element is greater than our top, they are using the binary search. After that they are finding the smallest index and take the difference from current index minus smallest index. Every time they are doing same thing and return the ramp. Now this is, but the concept here is n log n time complexity. But the third concept is this is also This is also a very simple one. Same approach we are using here, but here is n log n we are using, right? But interviewer ask you ki, is there any other way to do that of n log n to o of n or like that? Yes, we can do it. Here we are using same concept here of the array, but there is some small changes here. There is some small changes we can use here. First we are printing whole array, copy, now paste here. We are using same concept here in the solution third. Here in the previous case, basically every index we are checking, every index value is greater or smaller. Every index we are checking the current value is greater than our top element, then we are using binary search to find the which element will be our possible answer. If the value is smaller, we cannot check because we don't have, we cannot find the answer from the current index because index value is already small. Now here the third concept is basically says that ki, why we are using binary search. Can we say that we will find the all the minimum value in our array? Like let's say for in assume that this is our array. In this array currently we are standing over at index 0, right? We will insert it at index 0 here, right? After that we are going from the index 1. At index 1 we are checking the current top value will be 9 and the bottom value is 8. Can we say that we can, this is also decreasing, right? We are finding the decreasing element. What is the decreasing element we have? Again we are going from 9, but already we got the decreasing one 8. There is no any use. After that we are going from next step. Here is another decreasing element we got here 1 at index 3. Next element is index 4. After that every element will be, no element will become. This is our like stack. You can assume that is stack or list, right? After that we are storing all the decreasing element, right, in our answer. Can we say that currently we are standing over at index? Again we can traverse our, we are storing all the smallest element, all the decreasing array element into our, we are storing the indexes of all the decreasing array element, right? After storing, now currently assume that again we are traversing our array in right to left. Let's say for here currently we are standing over at 1, currently at 1. The value of which value they will take it, because if the value here is 1, this is the final value. We are checking the smallest element in our array. We are already storing in our st. This is 1 and 0 is the possible one. This is the smallest element in our array. The second is smaller, first is smallest, second, first is smaller, second, third, right? Now here currently here is 0. Can we say the difference of this both, this value and this value? We can say that, yeah, this is possible. 0 1 2 3 4 5 6 7 8 9. That's mean 9 minus 4. It is possible, right? That's mean 5. 5 is your answer possible. After that this will be a smallest answer because this will be a smallest answer. We are currently standing over at last and we are just taking the difference. We can pop it because no other element will be give the maximum answer. This is our maximum answer for at index this case, right? After that from next value they are checking the next value. Next value is 1 at index 3. That means the answer will be updated to 6 because the difference between both of them is 6. The condition is met, the current value is 1 and the top value is 1 and the current value is 1. After that the condition is met and nums of I less than equal to nums of j. We can pop it. the answer will be 6 here. After that we are again checking, the again value is 8, the value is greater than the current value, we cannot take it. Again we are going to back here for 4 doesn't meet because because the current value is 8, this is not equal. Again we are going to fair, same here because current value is greater, because top value is greater. Again here, again come to here, the top value is 8 but index, we are currently index at value 9, we will take the difference of both, we can pop it, the what is difference is 1, but already we have a maximum answer, we cannot update. Now here again we are going from at index 0, at index 0 we are checking both the difference, will be the value of both is same. Again we are taking the difference value is 2, but already we have updated answer, we cannot take it. After stack is empty, we are going from here, stack is empty, we are going from here, stack is empty, the final answer is 6. Now in this case basically first we are storing all the decreasing element indexes into our array, and from last we are checking, because in the last is your final, this is a final call, right? In the final call they will check in a stack st or set st is this top element will be smaller than the current element. If it is yes, this will be the answer. For this case we are checking from, if it is smaller then we are checking for stack, we can pop up the element and check for again top element. When we are doing same thing, when current top element will be not greater than the current index value. After that same thing we can do that up to right to left. If stack is not empty or our traversal is not complete yet, the time collapse this one is O of n, spaces of this is O of n, because we are using here stack st. Okay, I will show you the just code for this one. Question is tough, not tough, question is understandable basically. Now here is, we are using here a stack. After taking the stack we can store all the decreasing value into our stack, value indexes into our stack. After that we are calculating the ramp here, we can traverse our array from right to left and check if the st dot size is 0 and the top element of the stack is smaller than the last element or nums of I. That's mean this is the possible answer, because nums of I we assume that nums of j, and top element we can say that nums of I. That means we can update our ramp and we can pop that element. Same thing we can do that if condition is not false. Here this is O of n solution. Yeah, thank you so much for watching this.